I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach in this semester is digital communication, and the topic that I discuss today is QPSK, quadrature phase shift keying, and second, incoherent schemes, DPSK. Well, QPSK is a kind of, you know, is a kind of PSK. The only difference is in PSK, the phase shift, the, the phase shift is either 0 degree or 180 degree, but in QPSK, there is 4 types of phase shifts depending upon the symbol, and symbol consists of 2 bits. Means in QPSK, we have to combine 2 bits. If you have a long string of 1 and 0, what you have to do? You have to combine consecutively or neighbor bit, so you can have a pair of bits. So when you combine a 2 bit, you have only 4 possibilities. Either the combination is 0 0 or 0 1 or 1 0 or 1 1, right? So these are the 4 possibilities, and each combination is termed as symbol. So you have 4 symbols: symbol 1, symbol 2, symbol 3, symbol 4. Symbol 1 means 0 0, symbol 2 means 0 1, symbol 3 means 1 0, and symbol 4 means 1 1. So your carrier, which is a high frequency signal, which is a sinusoidal signal, is to be changed its phase, keeping frequency and amplitude constant in 4 different ways, right? So your high frequency signal, which you called as a carrier signal, is changed its phase in 4 different ways depending upon the symbol. If the symbol is, for example, say symbol 1 that have 0 0 bits, 0 0 combination of bits, then there is a 0 degree phase shift. When your carrier faces a symbol 2, then it's a phase shift of 90 degree, and symbol 2 means 0 1. When there is a symbol 1 0, then there is a phase shift of 180 degree, and when the symbol 4 come in the picture that have the combination of 2 bit 1 1, then a phase shift of 270 degree. So in this way, your QPSK means quadrature phase shift keying, and quadrature means 4. So 4 different phase shifts are possible in a quadrature phase shift keying. So the quadrature phase shift keying, QPSK, is a variation of BPSK which send 2 bits of digital information at a time called digits. So when 2 bits combine, then we call as digits rather than digits, right? So instead of the conversion of digital bits into a series of digital stream, it converts them into a bits pair. That this decreases the data bit rate to half, which allows space to the other users. So what happens when you perform, and if you compare with PSK, QPSK requires half of the bandwidth because data bit, the number of data bits reduced to half. So the bandwidth requirement is also reduced to half. So your capacity to send more information increases as you compared with PSK, right? So number of bits required to send the information decreases, so that the bandwidth requirement is decreases. So your capacity of sending more information is increases. So this is the very specialty of this QPSK if you compare with PSK. So look at the waveform. If you look this particular waveforms, 2 waveforms, this is your carrier. This is an unmodulated wave. This is your unmodulated carrier having same frequency, same amplitude, same phase, right? And this is your information 0010 0111, right? So this is your information in digital form, 10 form. Look at this. Now this particular unmodulated carrier is become modulated one. How that's possible? This is possible if this high frequency signal, which you call as a carrier, change its phase according to the symbol 1, 2, 3 or 4, or you must say 0, 1, 2, 3, right? So according to this bit stream, this particular signal, which you call as a carrier, change its phase, right? So you also remember that when 00 come in the picture, there is a phase shift of 0 degree, then 90 degree and 180 degree and 270. So there is 4 ways to change the phase of a carrier signal, right? So they look in the look this particular figure 00 and 10 come in the picture, then this is the point where the phase shift is the phase shift. Again there is a phase shift when there is a transition of 10 to 01. Look at this. And again there is a phase shift when there is a transition of 01 to 11. Look at this place. So every time there is a transition of one symbol to another symbol, at that point there is a phase shift, and the phase shift depending upon the combination of the bits, right? So next slide clear you this particular concept more. Look at these bits. If you have information in 0, 1, 1, 0, 1, 0, 1, 1, 0, 0 form, and look at the modulated wave that you call a QPSK wave. This is your QPSK wave, right? So 0, 1, look at this, same amplitude, same phase, same frequency. And when there is a transition of 0, 1 to 10, look at this. There is a phase shift. Here there is a phase shift. Then 10 to 10, there is no phase shift. Look at this 10 to 10, no phase shift. But when there is a 10 to 11, there is a phase shift there. And when a 11 becomes 00, there is a phase shift there. So in this way, this particular wave change its phase in 4 different ways, depending upon the number of bits. Sorry, depending upon the type of the combination of the bits or the symbol. So if you have a combination 00, you have a 0 phase shift. If you have 01, you have 90 degree phase shift. If you have 10, you have 180 degree phase shift. And if you have 11, you have 270 degree phase shifts. And this is the constellation diagram to that. So each 0001 there is a phase shift of 90, then 180, then 270. So start with this 0, 90, 180 and 270, right? So in this way, this high frequency signal change its phase according to the bits, right? The bits mean 2 bits. The bits is a combination of 2 bits. Now come to the topic, differential phase shift keying, DPSK. In differential phase shift keying, in short you can say that DPSK, the phase of the modulated signal is shifted related to the previous signal element. Means the phase shift is according to the previous bit, right? So when there is a phase shift, present phase shift depends upon phase shift actually depends on the present bit, but present phase shift depends upon a previous bit. So no reference signal is considered here. The signal phase follows the high or low state of the previous elements. This DPSK techniques doesn't need a reference oscillator. So this is the following figure that represents the model waveform DPSK. So look at this particular waveform. 0, 0, there is no phase shift. 0, 1, then there is a phase shift. 1, 1, there is a phase shift. 1, 0, no phase shift. 0, 1, there is a phase shift. 0, 0, 0, no phase shift. So this is the differential phase shift keying modulated wave, right? So the present phase shifts actually depends upon previous bit. So what we seen from the above figure, this particular figure, if the data bit is low, that is 0, then the phase of the signal is not reversed but continued as it was, right? If the data bit is low, that is 0, then the phase of the signal is not reversed but continued as it was. If the data is high, 1, then the phase of the signal is reversed as with NRI invert, right? So whenever 1 come in the picture, there is a phase shift, and for the 0, 0, there is no phase shift. So this is a transition 0 to 1, then there is a phase shift 1, 1, then there is a phase shift 1, 0. But there is a, when there is a continuation of 0, 0, there is no phase shift. Then DPSK modulator, where you get this DPSK waveforms. Actually, DPSK is a technique of BPSK, bipolar phase shifting, in which there is no reference phase signal. Here, the transmitted signal itself can be used as a reference signal. Following is the diagram of DPSK modulator. So this is a there is a XNOR. XNOR have two inputs. One is the present data input, present bit, and this is the previous bit, right? 1 bit delay here, and this gives the result. And after that, there is a balance modulator. One of the input is XNOR output, and one of the input is carrier, and you get this DPSK. So DPSK encodes two distinct signals, that is the carrier and the modulating signal with 180-degree phase shift of each. So the serial data input is given to the XNOR gate, and the output is again feedback to the other input through 1 bit delay. So the output of the XNOR gate along with the carrier signal is given to the balance modulator to produce the DPSK modulated wave, right? So output of the XNOR and carrier is one are the two inputs of this balance modulator, and you get the DPSK. And XNOR have two inputs. One is your present data input, and another is your previous your output 1 bit delay, which is the input of XNOR. Now DPSK demodulator. In DPSK demodulator, the phase of the reverse bit is compared with the phase of the previous bit, and following is the block diagram. So if you look the block diagram DPSK demodulator, you have a DPSK signal and you have a 1 bit delay of this DPSK signal, and these are the two, that is the inputs of balance modulator. This the output of the balance modulator goes to LPF, low pass filter, then shaper circuit, and you recover your binary data. So from the figure, this particular figure, it is evident that the balance modulator is given to the DPSK signal along with 1 bit delay input, and that signal is made to confine to lower frequencies with the help of LPF. Then it is passed to a shaper circuit, which is a comparator or a Smith trigger circuit, to recover the original binary data as the output. So again, I give you certain concept. Again, in QPSK, you combine 2 bits, and you then when the combination of 2 bits, then there is a symbol. The symbol consists of 2 bits, right? So there are 4 symbols that may be possible in QPSK. Symbol 1, symbol 2, symbol 3, symbol 4. Symbol 1 have 0, 0, symbol 2 have 0, 1, symbol 3 have 1, 0, and symbol 4 have 1, 1, right? So this is the 4 possible combinations, and this is the corresponding phase shifts in a signal. So in this way, QPSK modulated wave is formed, as you seen in this figure also. thank you very much. So this is all about QPSK, and I think this is also very important as far as the examination is concerned. So students should go through this and prepare well this particular topic, QPSK and DPSK. So thank you very much.